Today we will be looking at the second half of section 5.2. We are picking up with example 8. I need to find the integral of tangent of x dx. Now we don't know the actual integration of tangent of x. It's not one that we've had to memorize yet, but we can use a trig identity to help with the integration. So instead I can integrate sine of x over cosine x dx. I can rewrite it as sine of x times cosine of x to the negative 1. Then I would have to use pattern recognition to let my inside part be cosine of x. The derivative of cosine of x is negative sine x. So in order for pattern recognition to work, I need to put a negative out front of my integration and a negative in front of sine of x. So now when I go to integrate, I get negative the ln of the absolute value of cosine of x plus c. Example 9 is a very difficult problem. You will not be responsible for something this hard, but I would like to go through the algebra together. So I want to integrate secant of x dx. Now again, this is not one that you already have memorized. So what we're going to do is we're going to multiply secant of x by secant of x plus tan x over secant of x plus tan x. Now normally you would not think to multiply by that. That's why this problem is so difficult. So when I distribute the top, I get secant squared plus secant of x tan x all over secant of x plus tan x dx. Then when I bring up the denominator, the denominator becomes secant of x plus tan x raised to the negative 1. So I try to use pattern recognition, and my inside function is secant of x plus tangent of x. The derivative of that is secant of x tan x plus secant squared. Therefore, the derivative is in the integration, so I can go forward and integrate it, and I get the ln of the absolute value of secant of x plus tan of x plus c. Now, we could prove all of the other trig functions in a similar manner, but we will not, and I will just tell you what the other integrations for the remaining trig functions are. Now here are the integrations for your 6 trig functions. We already know how to integrate sine and cosine. We just integrated tangent and secant in the 2 previous example problems, but there's also the integrations for cotangent and cosecant. You must memorize all 6 of these integrations. Now we can move on to example 10. I want to integrate the square root of 1 plus tangent squared dx from 0 to pi over 4. Well, first I'm going to try pattern recognition. So I'm going to let my inside guy be 1 plus tangent squared of x. The derivative of that would be 2 tangent of x secant squared of x. That obviously doesn't work. So what I'm going to try to do instead is simplify my trig function. So 1 plus tangent of squared is the same thing as secant squared dx, so I can do that substitution. And then the square root of secant squared just simplifies to be secant of x dx. So then from the previous slide, I know that the integral of secant of x dx is the ln of secant x plus tan x evaluated from 0 to pi over 4. So I'm going to plug in pi over 4 in first, minus, I'm going to evaluate it for 0. So when I simplify that, I could simplify it to be the ln of the square root of 2 plus 1 minus the ln of 1. I'd probably simplify that though because we know that the ln of 1 is 0. So a better answer would be the ln of the square root of 2 plus 1. In example 11, we want to find the average value of tangent of x on the interval from 0 to pi over 4. Well, if you remember, our average value formula is 1 over b minus a. Integrate the function dx from a to b. So I'm going to set that up. So I have 1 over pi minus 4 minus 0. Integrate tangent of x dx from 0 to pi over 4. When I do that integration, I get 1 over pi over 4 times negative the ln of the absolute value of cosine of x evaluated from 0 to pi over 4. I can simplify the first fraction to become 4 over pi, and then I'm going to plug in pi over 4, and then I'm going to evaluate my function for 0. Do that subtraction, so I get 4 over pi times negative the ln of the square root of 2 over 2 plus the ln of 1. We know that the ln of 1 is 0. Since the ln of 1 is 0, that part falls away, so my final answer is negative 4 over pi times the ln of the square root of 2 over 2. Here are the remainder homework problems for section 5.2. We will go over any of the ones from section 5.2 that you do not understand next class.